All right, so if you did your around the room correctly, it should look a little something like this. You have all your work shown. Maybe use birthday cake method to simplify your radicals. And if you did this correctly, you should notice a pattern. On the front, all of your triangles were triangles with two congruent legs, or they were isosceles right triangles. And all of your answers ended up being the length of the leg times radical 2. So, this is no coincidence. On the front, you have a special right triangle. It is a 45, 45, 90 triangle. On the back, you had different shaped triangles. It had a short leg and a long leg, and then it had a hypotenuse that was always twice the length of the short leg. Again, the hypotenuse is twice the length of that short leg. And that was a pattern for all the right triangles on the back. And you might notice that there's also a pattern with our answer. Our answer was always the short leg times radical 3. The length of the short leg times radical 3, once we simplified our answer. So again, this is no coincidence. On the back, we have another kind of special right triangle. And this is a 30, 60, 90 right triangle. So we're about to take notes on this right now. So today is the 24th. That's when you'll be taking these notes. And we want to be able to answer the essential question, how do I use proportions to solve for sides in a special right triangle? Now we're only going to be working through the front of the notes. We'll get to the back when I get back on Friday. We'll finish these notes up. Also, know that I am here today after school for tutorials. Thursday there's a late bus, and I will have snacks. So please come to tutorials so you can get a deep understanding of this and get some practice. So, there are two types of right triangles that have a special pattern based on their sides. They're called 45, 45, 90. Triangles and 30, 60, 90. Based on your knowledge of just triangles in general, you should recognize that if this right triangle, it doesn't matter if it's right, but if it has two congruent angles, then it's bound to have two congruent sides. It's isosceles. 45 and 45 would be base angles. So whenever you have a 45, 45, 90, the ratio of the sides is always consistent. There's a side that would be 1 unit, 1, and then radical 2. Now with the 30, 60, 90, again, there's a ratio of the sides that's going to be consistent no matter how you scale that triangle up or down. So in a 30, 60, 90, the side opposite the 30 is always going to be our side that we're going to label 1. Our hypotenuse is always going to be the side that we label 2. And the long leg is always going to be the side that we label radical 3. So, with special right triangles, one key piece of information to know is that all 45, 45, 90 triangles are similar and to each other. So the 45, 45, 90s are similar. And then all 30, 60, 90 right triangles are similar. So if we know that they're similar, and then we should automatically know that they're similar by angle similarity, then we also know that they have similar means, congruent angles, and proportional sides. So the sides of all right triangles that are 45, 45, 90 triangles are proportional. That means that we can use these numbers to set up a proportion and solve for any missing side. So when we set up our proportion, we're always going to put our ratios on top, and then our given values on bottom. What's given in our picture or on our triangle. So you might notice, we've talked about it a lot already, that a 45, 45, 90 is also a isosceles right triangle. So whenever we approach these problems, our first step is always to identify what special right we have. Do we have a 45, 45, 90 or 30, 60, 90? We are then going to label the sides according to these diagrams below. And then we're going to set up a proportion. Once you set up your proportion, you can solve for x or solve for y, solve for your missing side. So we have these examples. Example 1, 2, 3, and 4. We're going to do 1, 2, and 3 together. For example 1, we need to solve for the side x and we need to solve for the side y. Y'all know that we can only solve for one variable at a time in a proportion. So again, how are we going to set up our proportion? Well, first let's identify, do we have a 45, 45, 90 or a 30, 60, 90? We have a 30, 60, 90. So I'm going to label my triangle according to this diagram. Opposite the 30, I'm going to put 1. Opposite the 60, we're going to put radical 3. And opposite the 90, we're just going to put 2. Let's solve for x first. So we need to set up our proportion. I'm going to put my ratios on top. So that means I'm going to put 2 and 1 on top. 2 and 1 on top in our proportions. And then I'm going to put the given values on bottom. Well, what value on our triangle goes with 2? Well, that would be 8. 8 over x. And then let's solve for x. 2x equals 8. Divide by 2. Divide by 2. And x equals 4. Now let's solve for y. If we put our ratios on top, we're going to use 3, radical 3. We're going to use radical 3, and let's use 2. Radical 3 and 2. On bottom, we're going to put the side that goes with radical 3, which is y. And then we're going to put 2 over 8 again, and cross multiply. 2y equals 8 times radical 3. To solve for y, you simply have to divide by 2. It doesn't matter that there's a radical on the other side. We divide by 2 on both sides, and y equals, these are what interact with each other. 8 divided by 2 is 4. Y equals 4 radical 3. All right, let's do that process again, setting up proportions, but with a 45, 45, 90 triangle instead of a 30, 60, 90 triangle. We know that these sides should be congruent if it's 45, 45, 90 because it's isosceles. And so this side would be 6. And we want to label it with the rules above. So this side corresponds with 1, 1, and the hypotenuse we're going to label radical 2. And then we're going to set up a proportion. Remember, our ratios go on top. So I'm going to put 1 on top, and I'm going to put radical 2 on top. And then I put my given measures on bottom. Well, 6 is what goes with 1. It is the side that would correspond. These would be corresponding sides in these similar right triangles. So we're going to put 1 over 6, and then we're going to put radical 2 over x. X is the side that we're trying to solve for. Yes, there's a radical in our proportion, but we solve using the same method, cross multiply. 1 times x is simply x, and 6 times radical 2 is 6 radical 2. X equals 6 radical 2. It's a one-step equation, and we're done. And in fact, our radical is already simplified for us. We have one last problem. And here, what kind of triangle do we have? It doesn't say 30, 60, 90 or 45, 45, 90. But it does have these two congruent angles and a right angle. So this would have to be, if it has two congruent angles and it has two congruent sides. So it would have to be a 45, 45, 90 triangle. And if it's a 45, 45, 90 triangle, then we label each leg 1, and then we label the hypotenuse radical 2, and then set up a proportion. Again, our ratios go on top. So we're going to put radical 2 and 1 on top. But then what are we going to put on bottom? Well, what goes with radical 2 is this 5 radical 2. And then what goes with 1 is the x that we're trying to solve for. We cross multiply. 1 times anything is just itself. So 5 radical 2 equals radical 2 times x. Well, to solve for x, yes, this is a radical, but it's just a number. Don't be intimidated by it. This is radical 2 times x. So to solve for x, we simply need to divide by radical 2. When you divide by radical 2 over here, they cancel out, and we're just left with x. Over here, the radical 2's cancel out again. And so we get x equals 5. So each leg of this triangle is 5 units long. We're saving number 4 for tomorrow. Make sure you're working on your flashcards. Come see me in tutorials today after school.